Thank you, Melissa. I want to agree and add one point to the issue of formation and definition of a planet. And that is on the IAU working group for extrasolar planets. We were discussing whether formation should matter in our definition. And some of the observers said it should. All of the theorists argued against it for reasons that Alan stated, that we don't want to have to change the definition because we learn more about formation, and formation is more difficult to understand than what a body is, what its current characteristics are. And I will just leave with one additional sociological point, and that is, Melissa said, Plutophiles here, knowing in her introduction to Alan. And when we talk about the IAU and that it wasn't maybe representative of planetary science, this meeting isn't representative of planetary scientists either. There is a very, very skewed distribution. I don't think any of the scientists here don't think Pluto is important, and whether Pluto is important because it is the best, the brightest and the best studied member of this very large population of Kuiper Belt objects, or because it's a planet. That's not the scientific question. We agree that Pluto is important. The issue is where we draw the line in terms of definitions, what the objects that we teach the kindergartners are. There are 8 big objects, and there are a bunch of small objects orbiting the sun, known to orbit the sun.
Thanks a lot. Now, I'm going to open this up. We're thrilled to have discussion between and among the scientists and the experts here, but really we would like to invite the dialogue between the educators and members of the public and the non-experts here and the experts, many of whom are sitting up here in the panel. And so we would really like to welcome you and invite you, your comments, your thoughts, and your questions. And so I'm just going to turn it over to whoever may have a comment or a question. And I might ask you to, if you have a question and you want to direct it to a specific panelist, that might be helpful. Otherwise, I'll try to pick somebody and distribute the discussion somewhat evenly among the panelists. Okay.
I'm Bob Smith. I'm a freelance writer about space astronomy. Something occurred to me while listening to Bill McKinnon's talk, and I think it's come up several times. It has to do with this whole definition of a word, which is what we're really, what does a planet mean? And you raised the interesting point about satellites, moons, that are bigger than planets. And I think a lot of the discussion and battle over this issue is to try to come up with a definition, it appears to me, that will somehow exclude satellites, because satellites are less important than planets are. It seems that way. The idea has to revolve around a star rather than another planet. And I'm wondering if we drop that criteria and just dealt with size, it would just simplify things quite a bit. I mean, for example, binary stellar systems, they don't worry about whether one is a star and another one is a stellar moon. They're just binary systems. So I throw that out as a thought.
Are you saying that satellites are not as important?
No, I'm saying that I don't think it's important to. It's a planet. It could be a planet. Just as you were saying, I don't see any reason why we have to exclude them. But I think the battle over defining, coming up with a definition that was. This is not my position. The battle over coming up with a definition was an attempt to also leave those moons as moons and not as planets. And I think that's been confusing the issue. Am I clear?
Okay, I think you're getting at something. To me, it's really the question of, and whether, Pluto's status, it's a question of whether being labeled a planet makes you important or not. And I think it's all a question about importance. And I tried to stress in my talk that I thought satellites were important. I teach an undergraduate course called the Solar System, and eventually I get, of course, to the satellites of Jupiter. We have a vast amount of data now from the Galileo and earlier Voyager missions. And when I'm done with the week on the floor of it's every year, or every other year when I teach it, that someone or more than one will come down to the front of the lecture hall and they'll say, but I thought they were just moons. And it's like there's an implicit hierarchy. If you are a planet, you are first class, A-list, you get inside the rope to the club. And otherwise, you're nothing. And maybe it has to do with the fact that our own moon is not quite as active anymore. And therefore, we've learned a lot from the Apollo missions, and so it's considered it's a dead chunk of rock, and so it doesn't count. But, and again, if you don't take a course or read, you don't know about really the diversity and fantastic phenomena that are going out there. And so there's no real way around. I can't go around saying Enceladus is a planet. It doesn't seem right to me. But there's got to be some way to communicate that these are worlds in their own right. As worthy a study, let's say, as Mars.
Alan also wanted to make a comment.
Yeah, Robert, I thought that was a great question, and it's something that I've thought a lot about in the last couple of years. I'm actually very close to where you are in viewpoint. From my standpoint, owing to their attributes, I would classify objects like Titan, the four Galileans that Bill spoke about, Triton, as planets that happen to also be moons, in the same sense that some Americans in this room are just happen to be from this state, from Maryland. They can have more than one attribute. And after all, being a moon is simply a dent of location. And in the case of Triton, as Bill pointed out, this is an object that used to orbit the sun and just became captured through happenstance. I'll close by saying that this issue of satellites and hierarchy is probably one of public perception, but not one of scientific perception in the planetary community. And let me illustrate that graphically. Rarely, about once every 20 years, we're able to muster in planetary science what we call the largest class of mission, a flagship. There's now a flagship mission orbiting Saturn called Cassini. These are very rare and very precious. The next flagship is now going to be a mission to a moon. It's either going to go to Europa or it's going to go to Titan. And so I put that forth as prima facie evidence that in the scientific community, we're finding some of the most important things to do with our precious dollars have to do with the satellites. And it's not a function of where the object is or its status in the vocabulary at all.
Okay. Next comment, question?
I believe you said in the blue, sir, that we should not allow formation to come into definitions because of problems that arise. And I believe Alan Stern supported that viewpoint. And I just wanted to ask that how can problems be arising be a deterrent to having something in definition? Because if in some definitions we could have up to 1,000 moon planets and more, that's a problem. We'll have to overcome it. So I guess what I'm saying is, why do we have to be problem-free in our definition?
Can I just ask you to tell us who you are and where you're from?
Oh, yes. I'm Alex Klein. I'm from Montgomery College.
Thank you very much. And it's Dr. Weintraub, David Weintraub, I think you were addressing your comment to.
Yes, and Alan Stern, yes.
I think the question you raised, do our definitions, do our answers have to be problem-free? It's a good one. No, they certainly don't. It's the problems that drive science forward. It's the problems that get students interested in learning and in becoming scientists. So I have no problem if there are problems as part of our definition. In terms of the origins question, again, we just heard again about Triton. Triton had a different origin than its current position. Right? It started in a simple orbit, presumably around the sun. Now it's in a simple orbit around a planet, if we use all the current definitions. Did the object change? No. But it raises some very interesting questions, and those questions are the ones that are at the edge of science that people want to try to work on and solve.